Thank you very much. Can you hear me okay at the back? Great, okay, thank you. So yes, I'm Nick.Barringer, I'm a Solutions Architect working for PuppetLabs, and today I'm going to take you through a really quick overview of what PuppetLabs configuration solution is. I'm going to talk a bit about how you can scale up to manage large-scale deployments, such as HPC. Talk something about DevOps, continuous integration, continuous delivery, then take you through some examples with a few of my customers where they've used PuppetLabs configuration management in large deployments. Including, I'm going to talk a bit about how PuppetLabs use it internally as well, because we do use our own solutions. And then a short demonstration as well. So, in terms of the PuppetLabs technology, the company was founded in 2005. The founder was working at Logic at the time and realised that all was not right with the world in terms of configuration management. So he decided to leave and really go out alone and try to find a better way of managing servers, large deployments, etc., etc. And yeah, just like Ansible works, we've also got both an open source solution and an enterprise solution as well. So because of the fact we've been around for 70 years now, we've got a substantial amount of users out there around the open source product particularly, but also a significant amount of enterprise users as well. So 3.5 million downloads in the last 12 months, about 6,000 community members, and somewhere around 10 million nodes under management by Puppet. It's worth mentioning as well about our investors there. So investors, these guys are also users, so Google, I'm going to talk about those as a case study there, an investor of ours. Cisco, just like was being talked about earlier on, again, they're looking to turn PuppetLabs technology to their own requirement to give users a way of managing their technology. And VMware are a recent investor as well, who are looking to use Puppet's capabilities as part of their overall stack. In terms of ecosystems, it goes wider, so Juniper are there. Again, just like Cisco wanting to use Puppet to manage their devices. And again, Red Hat pop up again as a customer of ours, and we're part of their satellite product as well. So in terms of our customers, I'm going to talk more specifically about a few of these as we go through, but really just the purpose of this slide is to show that we've got good credible names in every single vertical out there. And I won't call any of those out now at the moment. Like I say, we'll talk about some specific ones as we go through. But back to what Puppet is. So when Puppet was being devised, really the new breed of systems sort of management tools were around there. Things like Logic, as bought by BMC, Opsware, as bought by HP. And this was sort of a step forward from using a whole bunch of different scripts. And they were pushing out sort of more, if you like, golden images and things like that, and pushing out packages. But again, very much the push kind of philosophy, a lot about actively managing the configuration of the various different nodes. So our founder, Luke Canese, his idea was to come up with a solution which would give you actual, if you like, fine-grained management of the various different configuration parameters that you want to manage on your servers, with the ability to go on and continuously enforce those configurations, change them, etc., etc. But also to move away from purely a push model, but to have a model where you can indeed push out updates via orchestration, but you can also have agents check in and ask at any given time, what should our configuration be? So, effectively where Puppet starts when you've got your operating system deployed, and you've got a Puppet agent on that operating system. And then you can use Puppet to push out the various different packages, application components, etc. that you want to have running on top of the operating system. You can use Puppet to roll out application versions and do all that sort of good stuff. And you can use Puppet to configure the operating system itself once the agent's resident on there. So, in terms of the management stack over on the right-hand side of the screen, first off comes the discovery part. The operating system comes to life, the Puppet agent's there, and it checks in with the Puppet server and it says, here I am. And at this point, we've discovered that you've got another node. And the Puppet agent will give some information about what that node is, what sort of operating system it is, for example, etc., etc. So you've got some good information now about what you want to do to go on and manage that node. Now I'm going to talk later on in our presentation about how you can have a fully automatic way of then taking that check-in from the agent and turning that into a fully automated way of configuring that node into whatever it's destined to be. But effectively, once the agent's there, we start to provision, we push out these updates, push out packages, etc., etc., and then move on to manage the configuration of that node for the duration of its lifetime until it gets torn down. I mentioned orchestration, so we use MQ Series for our orchestration engine. The reason for that is when we want to talk to a significant number of nodes, we need to have something that's slightly more reliable in direct communication, slightly more scalable. So we have MQ there as a guaranteed delivery mechanism. And then reporting. Reporting is all important. You need to understand not just what the current state of the enterprise is, but you need also to understand exactly what's happening on each of the nodes every time the agent is running. Are things fine at the start? Is anything being changed? If it's being changed, why is it being changed? So again, reporting is at the heart of Puppet Enterprise. So it's an agent server-based solution. In the center there, the Potion, that is the Puppet centralized server. And it's going to scale up to, in one case, 100 cores, driving that Puppet master server in a fail-safe configuration. Then we have the Puppet agents deployed out onto all the various different nodes in the enterprise. Again, completely cross-platform, so we can cover off Linux, Windows, Solaris, etc., etc. And then we have the enterprise console, which is dashboard-based. Now, in terms of the deployables, similar sort of concepts to other tools in the space, we call our management modules modules. And we have a public forge where people can put their modules up, share them, and you can download and start to leverage other people's modules. So, just to explain at a high level how it works when you run Puppet, it starts off with you configuring the various different modules that you want to configure. I'm going to talk more about those in a moment. But effectively what you're going to do here is to create all the instructions to configure your node to perform a particular role. Once you configure those instructions, you then want to be able to test them. So Puppet Enterprise has a no-op capability, we call it, which is effectively a simulation run. So what you can do is you can tell one of the agents, yes, this is how I want to configure my node with various modules and various configuration characteristics. And it will go ahead and it will effectively go through the process we call the Puppet run of configuring that node, but it won't actually make any changes. And then you'll be able to see exactly how it works. Did you get failures? Did things work successfully? You can look at that and you can understand the impacts of what would happen if you actually press the button and actually use that code. And then once you're happy with that, you can then go ahead and actually use it for real. Now people tend to do this in one of two ways. They either use Puppet in full enforcement mode, where the agents will, on a continual basis, enforce the configuration that we specified within Puppet. But some people choose to run in no-op simulation mode because they want to make changes within designated change windows, or they're not happy to hand over the full management of their systems to effectively a computer system. And then, whichever approach you take, you get reports, either saying what the delta is between what you have and what you wish to have, or telling you what's being changed by the Puppet agents. And the Puppet agents, as I mentioned, you can orchestrate them interactively, either through the user interface, browser, or from command lines, which you can obviously script or prompt or what have you. And then also the Puppet agents, which are deployed onto the servers, will run on a scheduled basis. And out of the box, that's every 30 minutes, but you can set that to be whatever is right for your requirements. And then just check in and just say, what should we be at the moment, how do we look against the central definition of the configuration. And in terms of the Forge, I mentioned this is the online repository for various different Puppet modules. And again, I'm not going to dwell on the particular modules there, but yeah, we've got lots of things up there, including OpenStack, as I mentioned by Apple works earlier, which we're going for certification of over the next few months. Now, in terms of the differences between Puppet Enterprise and Puppet Open Source, effectively, Puppet Enterprise is a packaged release, fully packaged, fully tested, of the open source components. So we've got over 40 different open source modules, which are out there being run really as individual open source projects. And what we do with Puppet Enterprise is to provide a guaranteed supported way and use them all together. So therefore, rather than if something doesn't work in concert with another module, you're having to go out to the various communities and try to find an answer from disparate groups, you're able just to use the support within Puppet Enterprise and go off and actually ask us why something not working the way we expect. So, and there are other technical differences too, but fundamentally, I think that's the one big difference. It's the testing, the packaging, you're kind of outsourcing that work to us, so you can get on with doing the high value stuff, like getting it to actually manage your environments and what have you. So, I'll take questions at the end. If you've got any burning questions as we go through, just shout them out. Assuming there are no questions at this point, let's move on then to how you'd use this to scale to manage a large environment. So, like I said, first off, you need to have your operating system deployed with a Puppet agent. And you can do that in a variety of different ways. I mentioned the VMware partnership, so that's one very obvious way of getting your operating system deployed with the Puppet agent deployed on that as well. And you can use other things as well, Vagrant, for example, Khobar, various different solutions that are out there. But once you have a Puppet agent there on your operating system, then we then have to start to construct the various different configurations we're going to use for the various different nodes. And we do this, as I mentioned, through modules. And the key thing here is to make the modules into effectively small, manageable chunks that do individual distinct functions. So, for example, up there we have an example of an Apache module. And all that Apache module should do is deploy the Apache packages and get Apache set up. Now, you're going to need to use Apache differently in different applications. So you might have different virtual hosts, for example. You might want to set a list on different ports. But you don't want to be specifying anything that should be set for applications or environments or customers inside your Apache module. You need to separate that logic out from the mechanics of how you actually get Apache installed, so that you can then deal with that separately. And the Apache module will then be something you've created, you never need to change again, but you can reuse in multiple different configurations. So we'll use the Puppet DSL to create a configuration. Now the Puppet DSL is a human-readable kind of self-documenting language that you'd use for almost all of the configuration that you do with Puppet. And it looks a bit like this. In this example, for managing the configuration file for Apache Server, we've got a resource type, it's called file, it's got a name, and the name there is the path and the name of the file. And then we've got some facts about that file that we wish to manage with Puppet. First off, ensure it's a file. It means if it's not there, put it there. Yeah? Ownership permissions, things like that. So again, it's something that's not difficult to pick up and learn. The starting course is 3 days. At the end of 3 days, you're writing modules, to manage Apache in a dynamic way, for example. But what it means you can do is you can get away from needing to learn to use one language, such as Ruby or Python or whatever, across the board in the enterprise. And when I come on to speak about continuous integration with DevOps, for example, you'll understand why that's important. But the barrier to using Puppet, barrier to entry is very, very low indeed. So a different example of managing a resource type, a user. So user, that's a resource type, the name is Nick. And again, various things we can manage about that user. Again, ensure it's present. What shell is this user set to use? What's its home directory, etc., etc. So the concept here is to have a resource type and then to have various attacks that you can manage about that resource type in this way. So I went to my website and I printed off the list of types currently available. And one of the first comments people usually make when they look at this, bear in mind, Puppet's been around since 2005, they say that's not particularly on the list. And the key point is it doesn't need to be. It's so powerful what you can do with the various different resource types there that gives you the core of what you need to do to manage any environment. We've got things up there like exec, so run a shell script or a batch file if you really, really have to. In Windows, you need to do that often for executables, MSIs, and things like that. We've got files up there, we've got users, SSH keys. We've got all the core things that we really need to have. But the key thing here is it's not an exhaustive list. Puppet is a platform. So what you've got here is the out-of-the-box supported ones that you get from PuppetLabs. But if you need to, you can code a bit of Ruby and you can write custom resource types for yourself to use. Now, an example of this is a module that PuppetLabs wrote and released. It's on our Puppet Forge, and it's our firewall module. So we wrote in Ruby a firewall module, and now you can see up there some examples of how you use that firewall module, again with the DSL, to configure various things around the state of the firewall, what you do with certain protocols, etc., etc. And that's the key point there, right? So you use a bit of Ruby, and again, it's not something everyone within the community would need to have, but maybe somebody or PuppetLabs can provide that expertise. And then once that's written, you then use the Puppet DSL to manage that, again, in my component fashion. Okay, so again, we're just defining how everything should look, and again, it will always 100% ensure your configuration is the way that you specify it to be. Now, the different custom type here of Postgres, and here, with this custom type, we're now managing things like permissions around databases, database tables, etc., etc. Again, just an example of how you can modify the Puppet resource types to suit your own requirements. But once you analyze your requirements in terms of a particular node, you then create all the modules that you need to manage that node. Let's take the example of the lab stack. So you're going to need, first of all, modules to manage Linux, maybe some things around the security of Linux, the user accounts, all those sorts of things. You're going to require a module for PHP, a module for MySQL, a module for Apache. But like I mentioned, this module should just manage those single technical elements. That's really all that they need to do. And then effectively, you've got modules that can be applied to anywhere that you need to use those particular technologies. And as an example, you can draw them together to configure a lab stack. So the question really now is, well, how do you start to put the specific configuration information around how you want to use this particular lab stack? Now that's probably going to be characteristics of an application, but it could also include environmental things around certain customers, clouds, what have you. And the way you do this, the separation of the deployment logic, like the configuration logic, from the actual technical implementation, is to use, in our case, something called Hira. And Hira is one of our open source modules. It starts with hierarchy. And effectively, it's a key value searchable repository, which you can write in YAML or in JSON. And in there, you can start to put the configuration logic that you need to use inside the deployments where you're going to use these modules. So an example of some text from Hira. I mean, first of all, we've got it here in YAML, and you can see, again, it's fairly easily readable. You can just go through there, putting in various different parameters. So in this example, when you deploy Apache, and Apache then goes off and it does a lookup into Hira and says, how should I be configured? It'll see Apache packages, and you've got there 3 different packages it needs to put on. So here, again, you can put things into Hira, you can put them into customer buckets, if you like, environment buckets, or common buckets, and you can start to override areas too. So you can build quite a complex hierarchy here, but again, it promotes reuse. The idea that you define things once or as little as possible. Now here's the same example here in JSON. Again, slightly more succinct. Again, very, very readable. Again, very self-documenting, much like the DSL that I've shown you that you use for public configuration. So that takes care then of how we deploy the modules, how we know which virtual host to set up, which list of imports, how the application should be configured, right the way from the application down to the operating system for any given node. But the question here now is, how do we do this in a turnkey way, a way that requires no human intervention? No one to sit there pressing a button again and again saying, configure this node now. And the way to do that is to use automatic classification. So, as an example here, let's say an agent checks in on a new node that's just been provisioned, and the node has been named with that node name up there. Now, it doesn't need to be the node name. It could be that you set an environment variable like that, put a flat file in there with this in there. There are a number of ways the public can discover that. And effectively, as long as we can pick up something like that, we can then use that to understand automatically how to classify any given node. So, for example, within Hira, we could have, for the customer A, part of this name, we could have a hierarchical tree or a whole hierarchical file that relates to that customer. And then we can go through and look up what sort of DB should they be using. In this case, MySQL 5. What OS is on that node, or should be on that node, Red Hat has Linux 4. So we can use this node name or environment variable or whatever to go into completely automatic configuration of any given node. And that's really the key to scaling this up. It's the ability to be able to have 100 nodes, 1,000 nodes come up in the cloud, in the data center, wherever, and have them automatically be classified and then have the modules deployed to them with the configuration logic without needing to have human intervention. It gives us this ability just to scale up. And again, we do this in PuppetLabs. But when we do large-scale testing, we run our 500 virtual machines in the cloud just like that. In fact, I think it's 800 now. It's gone up. And again, we're able to do a completely automated deploy and provision onto these nodes purely by virtue of the fact we're using tricks like classification from node names, and again, keeping the information inside Hira. Now, it's interesting too because obviously Hira is PuppetLabs repository that you get with Puppet Enterprise is there with its open source module as well. But it doesn't need to be Hira that you use. So, for example, when you're using VMware, you can get that information from VMware itself rather than need to store it outside of VMware. ServiceNow, they have integration now, they're just releasing for our solution as well. So you can catch the requirements that you have inside the ServiceNow repository and then have that work with Puppet so you can get your configuration requirements directly from ServiceNow. But it could be with NDC-NDB as well. And that really is then how you get this fully automated cycle that I've spoken about. You write your modules, you separate your configuration logic from the modules so it's stored somewhere else. You then have the Puppet run and the agents check in, find out what the configuration should be based on classification from the host name, and then report back to tell you if you've got any issues with the configuration of those nodes. And I'll show you that when we get to the demonstration through our user interface. Any questions at this point?
Can you talk about ServiceNow, what it is exactly?
Okay, you mean what ServiceNow is or what the integration is?
If I recall correctly, ServiceNow is a software as a service, right?
Okay, so great question. So what is ServiceNow? So ServiceNow it's software as a service and on-premise. You can have it either way. But effectively, it kind of started off as being like a help desk style solution, and it's now become a proper sort of full-on service management system. So you've got CMDB capabilities, event management, all the various different things that you get from a variety of different vendors historically to provide you with all your service desk and operational style capabilities. So ServiceNow, within their CMDB sort of aspect of their products, you would write in what the configuration should be for the enterprise, the various applications, nodes, customers, etc. And then what Puppet will do with the integration, Puppet will actually use that effectively as a classification engine, and it will take from there what it needs to take to understand how to configure applications, nodes, environments, etc. Okay, so moving on then to talk now about continuous delivery, continuous integration, and DevOps. Let's just define what those terms are first of all. And it is, again, slightly subjective. It depends on who you are and what you do and what your view of the world is as to what you make of these. But continuous delivery, to me, means the automatic configuration and deployment of your environments. It's the ability to start to have infrastructure as code effectively, so you're able to, in an automated way, have full environments configured using software such as PuppetLabs. In terms of continuous integration, that's a little bit different. Continuous integration doesn't depend upon continuous delivery, but it certainly makes it a heck of a lot easier. Continuous integration is about bringing together all the various different code lines you develop within your application and testing them on a more frequent basis. And again, there's lots of really good reasons to be doing this, but effectively continuous delivery is an enabler for you to practice frequent and very, very good continuous integration. And DevOps is a practice. DevOps is a way of lowering the historic sort of vertical silos around development, QA, production, and starting to have people team horizontally across those different disciplines. And again, I'll talk more about the benefits of that as we get through this part of my presentation. So continuous delivery. The idea here then is, as I say, to have your infrastructure defined as code. So we've got various different environments there in the top boxes, and then what we've got is the definition of those environments captured within Puppet. Now, this would be the various different modules I've spoken about, and then within the tools such as Hira, the configuration specifics about how you want to deploy those modules for any given environment. Now, some of these will be fairly similar, some of these will differ. Effectively, I suppose one very good question you could ask would be, well actually, I want my environments to be the same. Why have they got different configurations? Yeah? Making them the same is the whole big win with continuous delivery. You don't want to have different packages in your development environment from your QA environment, because guess what? If you do, when you take your code into QA, it's not going to run the same. So they really need to be consistent all the way through. That's the big win from this. So why have different definitions for them? Well, actually, in my mind, I don't think you want to have fully different definitions. You want to have a definition of what the environment should be like, what packages are in the OS, how you're going to harden it, etc., etc. And then you want to change it, because you might want to add some bits in when you move out of unit test to make it a bit bigger. But you want to effectively adapt the core image that's going to run through all of your environments. And again, you might want to have the definition of having, let's say, hundreds of machines for your large-scale test environment, which is going to differ from having perhaps a few machines for unit test. But again, specify the differences as you move through this chain. And then you're going to have, again, one source of the truth, which spans multiple environments. So when you come then to deploy those automatically, they will all look the same. Okay? So that's one of the big wins. Now, as an example of this, I'm not going to go into too much detail, too time constraints today to do that, but within Git, I've got an example here where one of my colleagues wrote a continuous integration demonstration piece, and you can see here they've used JSON to specify various different requirements. If we go and have a look quickly into one of those files, we can see it here, again, very readable, just like I showed you earlier on. We're specifying various different things. Again, I'm not going to go too far into those, but it's things like how to configure WordPress for this particular environment, maybe it's going to be different from the previous environment, how to configure NTP, etc., etc. So once you've got the infrastructure defined as code, so you've got your single source of the truth, mapping out the differences and the commonalities between your different environments, how can you really leverage them? Because the other big win here is speed. I mean, it can take sometimes days, weeks to configure an environment for test. Yeah? Then you're ready for it. So you've got this delay. I mean, it's a bit like a factory, you know, you've got things moving at different paces, and eventually everything moves at the slowest pace. Yeah? And you don't want the environments to be the slowest pace. That's going to slow down your testing, your quality improvements, your feedback loops, all that sort of good stuff, and ultimately slow down your product release. And the way to do this is to use automated tools such as Jenkins. So we've got here screen capture. Again, I'm not going to go into this in great detail, but the idea here is you've got a bunch of different steps which are defined within Jenkins. And this is part of the demonstration that we showed at the last PuppetLabs in San Francisco. And what will happen is in each of these steps, an environment will be run up, will be created, generated from the infrastructure as code that I talked about. And then some initial tests will get run. And then based on the result of that, either if the tests don't work, it will drop out, it will finish, and you'll get feedback, and it will say the test has failed, fix that, and then come and try again. Don't waste more testing time and resources. Or it will proceed successfully on to the next stage, which might be to run some more tests in the same environment. It might be to tear down that environment or provision another environment instead. Yeah? But ultimately, what you've got is you've got a continuing series of complex tests and more detailed tests moving through from left to right. And again, you've got the ability to drop out at any point. But because the environments are configured automatically, they come up very, very quickly. And again, you haven't got also resources sitting around, perhaps expensive resources, being tied up waiting for a test, or indeed waiting to be torn down after the test. It's all taken care of you by the fact that you've got fully automated continuous delivery. So just going over then the overall benefits. So first of all, consistency like I mentioned. One of the worst things is when you get the application release being thrown into production and it doesn't work because developers were doing something, changed, and never made it through the various different environments. By ensuring that all changes go through your Puppet deployment, it means that you've got full consistency, full control, and production is going to look the same from a technical standpoint as the other environment you successfully tested it in up to that point. That's really important. Less defects. Okay, because of this ability to have the standardization, we're not going to get defects cropping up that you've got to troubleshoot, that perhaps you've got to change, which are down to differences in the code. Okay, and speed of provisioning speeds up massively. So you can get, again, these environments run up within minutes or hours versus many hours, days, weeks. And again, reduce cost. Reduce cost because you haven't got people sitting around running up servers. You've got servers sitting around doing nothing. Yeah, you're actually operationally far, far more efficient within the service you're providing to the business around the products and applications that you're testing, but ultimately what to release or use. So that's continuous delivery. Like I say, continuous delivery really is an enabler for continuous integration. Continuous integration, if you wanted to integrate all your code and then test your code together, if you've got to spend a week setting up an environment to do that, then you can hardly do continuous integration very frequently. If, however, you can spend literally just an hour configuring your environment to do continuous delivery, then continuous integration can happen perhaps even daily. And that's really quite important because the more you test, the more you integrate, the more defects you find, and that's really, really important. So this is an example of a few code lines, just to sort of graphically illustrate what I'm talking about. So you've got the lines over there in red, they're people working on disparate different things, and then eventually these things get merged back into one central code line. That's the code line that you want to test for your next release. So if you have people going off doing development in different directions for too long, then things start to happen. They start to different technical choices, bits of the product start to become incompatible with each other, and then you start to have large issues to unpick when you integrate and test. If you get conflictions, the products might have crept in weeks ago, months ago. Again, that's really expensive and difficult to unpick. If you integrate as frequently as you can, maybe even daily, in some cases maybe even more frequently than daily, and test, then you're never that far away from when the problem started. So you can unpick it, go back, make sure everything gets on track, and you're going to have a far, far more successful development process. So yes, you'll find more bugs, but that's a really, really good thing. Because you find more bugs, you fix more bugs, the whole process is going to go far, far better. Okay. It changes the whole dynamics of the feedback to the architect's development. Rather than having one big feedback loop that happens maybe every month, 2 months, 3 months, maybe even less frequently in large development processes, you get lots and lots of little ones. So you've got iterative feedback, you can go back, you can rethink, it becomes very, very agile as a process. It kind of changes the whole philosophy you have towards how you develop. And another key one here as well is release applications more frequently. So in fact, what it means is not just that development can be speeded up, but you can do more frequent releases. You've integrated it, you've tested it, why not release it? But what that means as well is you can be slightly more creative now with how you play around with features and functions. Because you can try things out. It's not such a big deal to put out a subsequent release and change it if you need to. Let's say users don't like a change you've made or a feature, take it out, change it. You haven't got a 6-month, 12-month wait before we're ready to do another release with all the changes that entails. And that brings us on to DevOps. So you don't need to do continuous deployment, continuous delivery, continuous integration to do DevOps. You can do all these things individually if you like, but again, put together, it really becomes much, much more powerful than the individual bits. And DevOps, like I say, it's really about this horizontal teaming, the ability to have people looking after the infrastructure right the way through all the different environments. And the developers involved are responsible as well, outside development, but actually about helping to write the configurations for test, or how to deploy into production, about all those good things. So breaking down the barriers that historically exist within the development phase. And Puppet DSL makes adoption of DevOps very, very easy. I mean, like I mentioned, the starting course for this is 3 days. A lot of people also self-learn as well. You don't need to become a programmer to use this, and that's quite important because not everyone wants to be a programmer. You might have got developers that want to write Ruby, Python, development languages, and all that sort of good stuff. But what about some of the sysadmins that maybe don't want to do that? People that historically do application support, other sorts of roles. Maybe network support people in some cases. So the fact that you've got a DSL that's very accessible, that's very understandable, that's very readable, that's, you can look at it, you can make some sense out of what it's doing, is actually a really good if you like, enabler for DevOps, because it means everyone's got a tool they can use right the way across the enterprise. And now developers can start to configure things using Puppet DSL, and then people that haven't got a development background can understand what they've been doing, they can work with that, extend it, change it to meet their requirements as well. I mentioned about the higher abstraction. You can put that through version control as well. So, if you want to put the modules, for example, let's say through Git, version control those, you can do the same with Hira, you can do the same with just about every part of Puppet. Therefore, you also understand across the various different environments, across the different teams, that everything is as expected, and again, that nothing's been changed unexpectedly. You've got a whole change control process you can put in place around this if you wish to. And just to give you a slightly more in-depth version of the Puppet DSL, I've shown you a pattern that's very, very common amongst Puppet modules. What we've got here at the top is a file, a config file, its source is specified there. But the key thing here is that the package underneath this, the OpenStack server package, that has to be in place. You've got a before statement there, before the file that we mentioned at the start. This is the interdependencies that we need to establish within Puppet. Then we've got the service. But the service, the SSH service, subscribes to the config file. So if the config file changes, the service will restart. Yeah? Now, this is a bit different with Puppet because we're not linear in the way the code runs. The code's not going to run from the start and go all the way down. And I quite deliberately structured this example in this way to show that it doesn't do that. Because the thing is that when you use things always in a procedural way, there's advantages when you're dealing with very, very small scale implementations. Because you can see very clearly what's going to run. When it becomes bigger, and you're working with, let's say, a number of different modules, maybe 10, 12 different modules, a bunch of different environments, a bunch of different customers, it starts to become a bit unwieldy. So the way we like to do this is to say, well, let's not worry too much about the order of things necessarily, but we can specify where we absolutely have to have things happen in a certain order. So that's what we're doing here. And again, this sort of thing creeps into Puppet manifests, and it was a very good thing because it enables us to really enforce the idempotency I've talked about, because we can't be truly idempotent unless we understand how many things we need to change to fix one thing. So let's say, for example, you've got 100 different parameters under management on a server, and one of them ceases to be correct. In a truly idempotent world, you would change one parameter back. You wouldn't change the other 99, because it's the idea of changing them more than once that introduces issues. But let's say in this case, it's the configuration file that changes. Well, you also need to restart the service before you actually put everything back to the way it needs to be. So you need to call out that relationship to be fully idempotent. You can't assume that, and that's the reason that we do this. And so to wind off the DevOps part of the conversation, I've just got a workflow here which is around Puppet and Git. I'm just going to talk you through this. Can you see that again back? Is that sort of disappearing? Too small? It's too small. small. Let's see if I can enlarge that a bit. Okay, and I failed, I'm afraid. So, sorry, just bear with me and let me just take you through this. So the idea here then, the DevOps environment. So at the top there, the dark green, that's development activities. So development, they've got the application code they've written, they check it into the source code repository. Then they build the RPM using Jenkins, and they upload the RPM manifests, Puppet manifests these are, the development servers. And at that point, they've kind of done that, and it hands off to QA. So QA then, they've got this, they've got not just the application code, but they've also got the Puppet DSL that goes with it. So they've got a proper handoff now as to how to deploy that, and possibly even how to run certain tests against it. So QA in light green there in the middle, they're going to then promote the RPM and the Puppet manifest into their QA environment. They install all these latest manifests, and they change HIRA, so the configurations are now fully updated. As I mentioned, HIRA can be within your source control as well, so you can version control that. And they do their tests, and assuming everything passes successfully, you want to do a proper production promotion. It moves down to the bottom section there in orange, which is operations. And at this point then, they're going to promote both these deliverables, both the application code and also the Puppet manifest, modules if you like, to the production environment using the latest HIRA configurations as well. They're going to make any changes they need to make as part of their process, and they're going to put those back into source control. So they've got that all there, repeatable and under management by Puppet. So again, it's quite an elegant flow. I mean, the key thing here is the fact that the Puppet configurations pass along through that cycle alongside the application code as well. Okay, so I've got just over 20 minutes left. I want to talk through the examples and have time for a quick demonstration. So I'm going to move a bit quicker through the customer examples. But to start off with, PuppetLabs. So there's a wonderful phrase, which is that we eat our own dog food. We use Puppet internally within PuppetLabs to manage the entirety of our testing process. So in terms of the open source, I've mentioned there's over 40 modules. I think of this as being unit testing for Puppet Enterprise. Puppet Enterprise includes all those different modules. We do 4 releases a year, patches as well. And in release cycles, we're testing once a day, Puppet Enterprise. And this is a snapshot of the whiteboard that maps out what that testing infrastructure looks like. So we've got GitHub at the bottom, we're using Jenkins to automate things, we've got some builds at the top which are driven by Jenkins. That all goes into a distribution server. Again, we've got a test harness which again has been written and leverages Jenkins as well. And then we've got the ability to do tests internally inside our own virtual machine repositories, and indeed to do cloud tests as well. The key thing here is we've automated the building, and also we've got fully repeatable testing of the code, it's all automated. I talked about the Jenkins workflows, and again, same for ourselves. Our pipeline gets progressively more complex as you move through it, so it starts off simple, with a simple test pass, we move on and do more complicated tests. And it's a fully collaborative effort between development and operations. But the other thing that surprised me when I started working at PuppetLabs, and I started to get underneath this, is how small the team is. So we've got a team of 8 in our QA managing both those products, which is a huge amount of work. And I spoke to them about this, and I asked them, well, how did you get to where you are now, with everything being so automated with such a small team? And then they said, well, we really had to stay with it. It was not an easy undertaking, but we started off and we wrote an awful lot of code. We wrote some of the custom test harness. We wrote an awful lot of Puppet. And then gradually things got better, and we sort of got over the mountain, and we started to really leverage more of what we've written. And again, just start to make smaller changes to that as we go forward. But an SQA team of 3 can service in excess of 20 developers now. And again, like I mentioned around DevOps, devs own the testing as well, and write an awful lot of the tests in Puppet to pass along with the various different releases that go into quality assurance. So what we're testing, there's over 800 GitHub repositories that have been drawn on for these tests. We're testing 60 different operating system platforms, 50 different unique test configurations with 7 browser versions, various different versions of Ruby, and again, a whole bunch of different modules as well. So what they're testing is quite vast. There's an awful lot in what they do. And again, as I mentioned, progressively the testing gets more complicated from unit test, integration, acceptance, right up into a fully cloud-based scale test, where they'll be testing in hundreds and hundreds of nodes. Okay, so yeah, in terms of the scale testing, which happens in Amazon's cloud, that's in excess of 800 nodes. database. So again, all this is run up automatically from Jenkins using Jenkins and Puppet. There's no human person sitting there pressing buttons or making decisions about this. The whole process is automated. Okay, so that's the way we use it at PuppetLabs. Moving on then, so I'll give you 4 different examples. So Google, first of all, they're a small search engine provider, you've probably heard of them. They've got 64 offices around the world, 43,000 employees, actually over that, all using Macintosh laptops. And the challenge Google had was, well, how are they going to manage these 43,000 plus users in a automated way? They're all mobile, they've all got different requirements as well. Some people are fairly basic users, so they're using standard sort of productivity tools like Office stuff and email and what have you. Some of them are developers, and everyone loves to muck around and put stuff on their laptops and do their own thing. And again, there was a culture of that as well, which makes automated management quite difficult. So, in setting off with this, they decided they wanted to have 3 principles around how they would do this. One was it needed to be reviewable, you need to understand exactly what they were doing, and you need to be able to see the results. It had to be repeatable. They had to be able to, again and again, enforce the configuration onto their users' laptops. And it had to be automatable as well. So, in terms of the steps, the first step, make a golden image. This is the basic image that will be applied to all the various different laptops, all 43,000 plus of the laptops. And then work out how to configure the various different types of laptops to meet their users' requirements. So how to classify that user as having a certain set of requirements, and how to do that fully automated configuration. And then they wanted to then continuously enforce the configuration using the configuration management tool. So the approach they took to this was, just like I mentioned going through earlier on in the presentation, they bootstrapped the OS and they included the Puppet agent with them. Now, they didn't use a central Puppet master server to send out updates. They actually pushed out files through a different mechanism. And their reasons for that was because they've got various security constraints in place within the network, and again, their clients are mobile. So they wanted to use a different delivery mechanism to send information to their laptops. But they've got a Puppet agent resident on each of these laptops. So users, as they're out, they're mobile, they're not connected, they are connected, they're doing lots of different things, but Puppet is there on their laptop, continuously enforcing the configuration that's been specified by Google. But they have other tools as well. And they also want to be very, very fail-safe. So they've got other tools which want things like, for example, firewall configuration and other sort of, more basic elements of the laptop. And those tools also will invoke Puppet if there was something wrong with their view of the world. And they get Puppet to try and put that right. What they also did was they also had shell scripts which could be invoked as well, because that would run on a scheduled basis and just check to make sure Puppet was okay, everything else was okay. And if nothing was working apart from the shell script, it would go ahead and do a full installation of Puppet, and Puppet would then take care of installing everything else, and effectively that's the get out of jail card to get everything back up to rights. So that worked really, really well. They use Factor, which is a module that reports back lots of environmental information about the host, to send back details to their inventory. And they found that things happened, like, for example, they were able to do an iOS upgrade in 8 weeks across over 43,000 Macintoshes successfully by pushing out the changes via Puppet. And again, they really liked the fact that there are a bunch of Python programmers that didn't want to have to learn Ruby, so they wrote a very small amount of Ruby. Probably custom types providers like I've shown you, but the majority of it was done using the Puppet DSL. Okay, so next example customer is CERN. So these are the guys that they're out in Switzerland. They've got the Large Hadron Collider. They're looking for the Higgs boson particle at the moment. They also invented the internet, which is their other claim to fame. But they're trying to answer other questions too, such as what's dark matter, what's antimatter, where's 96% of the universe gone, because 4% is what we can see and measure. They're doing lots and lots of fairly tricky things. And they've got fairly significant requirements around the computing infrastructure to support that. So the Large Hadron Collider, well, that's 27 kilometers long. They've got a huge campus, which it's on as well, to house that. And protons go around the Large Hadron Collider about 11,000 times per second. Now, in terms of capturing this Higgs boson particle, they're hoping to smash protons into each other and capture the moment at which they collide, which will give some clues as to what happened when the universe originally started, apparently. And what they've done is they've set up points, 4 points around this 27-kilometer loop, where they're capturing data, effectively using cameras to take photographs of what's happening with the particles being sent around in the collisions. What this means is they're taking 40 million images per second when this is running, which is 1 petabyte of data. So that's what's being generated. They're currently storing 25 petabytes of data per year. That's going to grow, and they're slightly concerned that the business requirement is to keep that data for 20 years. So they've got phenomenal data storage requirements. So what drives all of this? Well, in their central compute center, they've got 64,000 cores of white box computing power. Now that's not enough, so they're farming out batch processing jobs to 200 different subcenters, which are doing 1 million jobs each per day, kind of a grid kind of structure, and then sending results back to the centralized computer facility. And to support those 64,000 cores, they've got 64,000 disk drives, that's 73 petabytes of storage, and they're having to store all of that data. So basically, alongside all of this, they realised that they had to provide an increase in their computing power, and having been really the first ones to deal with data on this kind of scale, they kind of home-baked all of their infrastructure and management to this point. But they took a look around, they said, well, maybe we're not quite so unique now. The world's changed since we originally worked out how we wanted to manage the original infrastructure. So they looked around and they realised that yes, in fact, there are other companies out there that have got similar requirements. And Google's one example of that. So having had a look at what's out there, decided to move to a tool chain in the same sort of style as Google, for example, using things like Puppet and OpenStack. And in terms of using Puppet to manage their infrastructure, they've got 100 CPU cores, just driving the centralized Puppet master server. And that manages 15,000 hypervisors and 300,000 virtual machines. So that is our largest deployment worldwide. Okay, so next one, NICS, the National Institute for Computational Science. So this is an academic supercomputer. It's one of the largest in the world, definitely one of the largest in academia. And in terms of its size, it's got 16,500 compute sockets, it's got 129 terabits of memory, and it's got 3.3 petabytes of disk space. Now that sounds huge, but I think probably certain to fill that in about 2 seconds. Either way, it's huge. It provides services to 2,000 active researchers, around about 700 million CPU analysts per annum. They have a requirement, again, to look at how to manage the configuration of the system, and their objectives were, first of all, it had to be centralized. They wanted everything automated, no manual setting up the servers, no running of scripts, and they wanted to have all their changes go through one central point. So that no maverick changes, no different versions of scripts and tools around, everything fully centralized. And they wanted to get 95% uptime, so a change in reliability. And they also wanted to take a more holistic approach to configuration, so look at it more in terms of entities rather than scripts and stuff like that. So they went ahead and used Puppet, and the benefits they saw, first of all, security. That was a really big one for them. The ability to be able to say, yes, we understand that everything is configured exactly the same from a security standpoint across all of our various different nodes. Consistency. This was more of a perception that things really weren't working in a consistent fashion. And again, using Puppet, using idempotency, they were able to say, yes, we can provide consistency right the way across the entire computing estate. And again, that's been borne out from their experiences with it. Centralized operations brings efficiency, absolutely. Again, you can automate a lot of this, it saves you time. It means you can get on with doing other things. System deployments now taking about an hour, that's down from 4 to 6 hours. Again, the admins now, sysadmins are doing far more higher value things, rather than spending their time actually managing provisioning servers and stuff like that. And the last one I'll talk about is a case study around Amazon. It's not really Amazon, it was Amazon being used by the people that ran Barack Obama's election campaign. This was a bit different. First of all, they didn't really have much money because the campaign hadn't started, so there was no funds. So they had to really start drawing on volunteers and people that would work for effectively very little money to get this done. This was the 30th biggest e-commerce operation globally at the time, and they were writing some 200 applications to support the campaign. Many of those were web applications. This resulted in hundreds of terabytes of data, but again, coming into disparate applications that had to be integrated, and the applications had to have mechanisms for talking to each other. And the other slight wrinkle they had here was because they were drawing on a large volunteer base, people were writing applications in languages that they were familiar with, rather than going for a defined standard. So again, there was an awful lot of complexity amongst the applications, not just through the amount of those. And again, spiking user traffic. It's going to ramp up through the course of the election campaign, but you get spikes at various different points when interesting things happen, quotes, tweets, etc. come out. And they have a movable deadline. So they had 18 months from architecture through to deliver, and they had a year, effectively, to get everything done. they did this with 40 developers, and they used DevOps as part of this too, so 5 of their developers were working in DevOps capacity as well. So I'm not going to dwell too much on this, but effectively they use Puppet within their deployments, managing the components within the Amazon Web Service Cloud. They effectively had multiple Puppet masters for fail-safe and also for scaling up. And these Puppet masters were able to build off each other. So you could configure a completely new Puppet master server based on the other ones that were already present in the enterprise. And they had a mechanism for if anything disastrous happened and you lost them all, then you'd be able to rebuild completely from scratch. And they also use Puppet to automatically install packages, so you can put hooks into Git and things like that, and again have Puppet automatically deploy packages when they get updated. And just a few figures here, so they had to go ahead and duplicate their environment because they only have one environment on one coast, and they did that in 9 hours. They used Puppet along with Amazon Web Services to really stand up these 200 applications. There was data copied across as well, which took 4 hours, but they were able to replicate the entire deployment of all these 200 applications, data, everything in 9 hours. Again, that's part of the power of using configuration and automation around things like Puppet. So, my talk today. Can I get some questions now? Or not?
Questions?
Okay.
Actually explain how to do it from the management side. You enforce some policies and you try to do it from the management. I would like for you to explain how to do this from technical, the best practice, how to implement Puppet in technical, best practice model.
I'm sorry, I'm not fully understanding your question, so can you just restate please?
Yeah, you explain how to enforce Puppet from management perspective.
Yeah.
I would like from you to explain from technical way how I can implement Puppet in my environments.
How to deploy Puppet?
How to deploy.
Oh, I understand. Right. Okay. Sure. Okay. So, yeah. So in terms of the Puppet Master Server, if you go with the enterprise solution, that's a full installation file. So it's one single installation file that you install, and you can choose to install all components onto one Puppet Master Server, or to break them out. Yeah, so you can put the database separately, you can run the dashboard separately as well. That gives you the ability to effectively do some vertical scaling around your Puppet deployment. Yeah, you can also horizontally scale it and load balance in front of multiple Puppet masters if you wish to do that. But in terms of the agent again, it's an installable file. You can make it part of the build, or you can install it after the build. But that really is just the 2 components. Yeah, I'm talking about the enterprise version here. Yeah? If you go with Puppet open source version, then you've got a whole bunch of modules you've got to go and get. You've got to install, package, etc., etc. Yeah. But yeah, for Puppet Master Enterprise, we install Ruby, it's vended, everything's vended. Yeah, one installation, and then it will all run.
Thank you, Nick. It was very interesting. It was very informative. I thought I knew about it, but there are lots of things that I didn't knew, and you highlighted them. I would like to know about your roadmap. What's next for Puppet, basically? You are trying to push the innovation in configuration management, automation, continuous delivery. So what is next? What is your next challenge? This is one question. The other question regarding content management database, CMDB. Now, Hiera basically saves our data, the data we define. And PuppetDB basically can be used as CMDB or can be integrated with an enterprise CMDB.
Sure.
And the third question is the user interface. You hinted while you were describing the user interface that maybe it's not usable for if it's a large-scale system or something like this. Can you elaborate on that?
Sure. Let me say the third question last. So in terms of the user interface, I think whenever you get into managing large systems, automation is really the big win around all the configuration management solutions. So the more you can automate, the better it gets. So what you don't want to be doing is spending a lot of time clicking in the user interface up the enterprise console. It's great for doing certain things. And again, because you can manage large groups, you can do filtering, so you can manage hundreds of nodes and deploy to them using the Puppet Enterprise Console. What I'm saying here is actually we have APIs that you can use for the live management as an collective, the orchestration part. We have, again, an awful lot of ability for you to use scripts or schedules to kick off some of this activity. And I've shown you how to automatically do things like classification, configuration, and stuff like that. So what I'm saying really here is that in terms of maturity, I think organizations will start off lower the maturity curve and they'll start to interactively use tools a lot during the early stage. And I think as they move on through that maturity curve, then they'll automate more of it, they'll be using more of the APIs, more of that sort of stuff, and less things like the user interface. Yeah? It'll always be a roll forward. I think the fault finding I've shown you just now is a really good use case for using a user interface. But for things like provisioning, making configuration changes, maybe less so as it becomes more mature. Now, in terms of the PuppetLabs roadmap, what's coming up, well, supporting modules is one of the things that's literally about to come out in our next release. So there's thousands and thousands of modules on Puppet Forge, but they're all put there, some by PuppetLabs, some by partners like VMware, some by third parties. And again, the point here is that whilst with Puppet Enterprise, the Puppet infrastructure is supported, we don't own those modules. We haven't done anything to validate those modules, therefore, they are not part of the support contract you would have with PuppetLabs. So one of the moves that's coming up is to actually start to go through and provide supportability around some of those key modules. So I don't have sight yet of what those exact modules are, but again, we're going to be picking the most obvious ones, but also meeting our customers' requirements too. So we've got a big customer that says, do you know what, it's a deal breaker if we can't get support around modules X, Y, and Z. We can work with them on that. Yeah? So it's going to be a thing that's driven from two different sort of aspects. In terms of roadmap too, VMware is a very, very big thing on our roadmap. We're going to have increased integration with VMware and more of their tools, more capabilities to give, again, more automated performance around the VMware stack. That's a very, very important focus of what we're doing these days. Additionally, more APIs to allow vendors to hook into our technology, and again, more APIs to work with other vendors as well. So you've seen ServiceNow and VMware as being two examples. We have Amazon and Google Clouds as well. Available with APIs. We're going to broaden that to more work done around that. Yeah? And role-based access control is going to mature as well. So yeah, all those things, I think the next few things that are coming up on our roadmap. Yeah? Okay, so there's one more question you asked me. Could you just restate that one?
The last question was regarding, you mentioned during your presentation that VMware is basically you can version control it, and I like this concept. So I was wondering, if we are going to use the CMDB, most likely it will not be here, because here is what we need. So most likely it will be PuppetDB. So is it possible to version control PuppetDB, or is how do you integrate with the enterprise CMDB?
Okay, good question. So in terms of version control of the PuppetDB is, first of all, populated by all the reports, right? So all the reports get generated from the agent are stored in PuppetDB, and we're querying that for some of the information that you saw in the demonstration. In terms of the configurations that are built up from the modules and Hira together, the modules and Hira go to make up that configuration. So they're the ones that you version control. Yeah? So I don't see a need to version control PuppetDB as such, because the artifacts that you use to actually build that DB are themselves version controlled in an ideal world. Now, in terms of would PuppetDB be a CMDB? I don't think it is. I think it has some aspects of a CMDB because you can query it for certain facts. So, if we move back to the view I had of the factor here for a particular node, let's just choose one. Then yes, you've got certain things in here that you may well wish to ask a CMDB. For example, you could create custom environment variables, custom facts that might relate to what rack a particular server is in. And you have that up there, so you can say, yes, we can see what the virtual machine is, yes, we can now see what the physical machine is running on, where it is in the data center, etc., etc. That's entirely possible. But this really is a subset, I think, of what people want to capture in CMDB. And you can augment this in the way I've just mentioned, but again, not in as many dimensions as a classic CMDB would be. So, yes, I mean, CMDB, some people love them, some hate them, everyone recognises the value to have them within large organisations. But I think more the key of Puppet is to be able to plug into other people's CMDBs and share this kind of information where it's appropriate and desirable.
We have a question. In HPC environment, we care what comes with the clients and nodes. And like Puppet, there are other solutions who use a client that runs on the compute node. We know most of the time it doesn't consume our CPU. But I have two questions. The first one, Have you come across situations where the other clients, like spikes of the CPU or memory, one percentage? The other thing is, what if we have other flavor of like Linux or proprietary solution that you don't have a client for? You develop this for us.
Okay, fine. So in terms of the performance, the Puppet agents don't use resources when they have to. So when a Puppet run occurs, the agent will retrieve the list of facts. It will send those back to the management server, and that will then use those facts, along with the name and information as well, to generate what we call a catalog. And the catalog gets sent back to the agent then just installs that. So you are going to get resources used if you go and install a package, let's say, or do some activity that requires resources and CPU time on the client. That would happen using any solution that's going to deploy that, including shell scripts or manual administration. So in terms of runaway CPU, we don't get that. What we do have is the ability in our client to spawn off separate threads for different processing tasks. So what then happens is a thread runs, when the task completed, the thread then gets disposed of. So you haven't got things happening inside a process, which is a classic case for a process to have a memory leak. Yeah? We've deliberately architected things in a way that can't happen. So the CPU impact from the Puppet agent is very, very low. Yeah? In terms of where you've got, let's say, a grid of computers, then I guess the other form of impact you could have is if they all decide to do Puppet at the same time. Because that way, whereas you might have a low impact on one node, actually across the entire cluster, that could then have an impact. Now, the way we deal with that is to use a variation which is basically based on the hash of the fully qualified domain name. And that puts some randomness into when the Puppet agent runs between the intervals with which it's entitled to run. So let's say you're running every 30 minutes, then it will be anywhere between 1 minute and 30 minutes in, depending on this hash. So that randomizes when the Puppet agents run, which means that when you've got a large deployment, made up of a certain matrix of computers, you're not going to get them going at the same time. And it's important too, because that minimizes disruption on our central server, which doesn't want to have a large amount of computers checking in simultaneously. I'm not saying it couldn't do it, but it's not ideal. Again, you have to put more power behind it if you have that kind of circumstance occurring.
What's the other half of the question, which is if we have a special flavor of Linux, so that doesn't have the client in the rest, will you? Or AIX, for example,
Sure. So we do have support for AIX already, but again, this is done on a case-by-case basis. So in some cases, it's relatively easy. It's just a testing sort of process to be able to take existing agent and then just test it on a different version of Linux. In other cases where you've got differences which need to be developed around, it's a different proposition. And again, all of that's really driven by the relationship, by commercial aspects and stuff like that. So absolutely, if the requirement's there and it makes commercial sense, it makes sense, then we did it, yeah.
Any more questions?
Yes.
We'll take the last question because some of you will do it. If they would like to leave, then we will conclude here. However, if you'd like to have more in-depth questions for the answer or what, we will go around the table. This one.
I have one question for Nick and then another question for Nancy, actually. When you presented the example, the use cases, you started with PuppetLabs, and it was an actually brilliant use case. Do you think in the future that you might make it as a product? For example, our developer was asking exactly this question. He was asking, we don't have Jenkins, we don't have a build server, we don't have a continuous delivery integration flow. But we would like somebody to help us out in setting it up and maybe maintaining it later on. As an enterprise, we like always have maintenance and support for that. So do you think that instead of just providing the core automation, can you provide the whole product for continuous delivery and integration as a product?
Okay, so a large amount of what you saw there was based on other open source solutions as well. So I think more and more what we find is that when we go off and we consult around Puppet, we have to be experts in all the peripheral stuff around it as well. Right? So Git is something that comes up an awful lot for us, for example, SVM as well. Absolutely. What we can do is through consulting as part of the architecture, deployment and everything else, we can work with you to transfer some of that knowledge. Yeah? We can open up more of what we've done, more detail around that as well, so that you can then take some of the principles and practices and build those into your approach here. In terms of natural products, I think it's one of these things that Requirements tend to vary, I think, from place to place. I think, it's one of these things, I don't know how tenable it would be to actually have it as a product, how much you could apply it, how much variation would be there. So that's not Puppet's current expertise, but certainly, yes, we developed a lot of expertise in-house, and we're quite happy to share that. So I think my answer is we can consult around that. We can certainly help you achieve something similar, if that's what you decide to do.
This is a question for Ansible, actually. Basically, it's the same question I asked Nick. In your roadmap, what do you see as a challenge, and what do you see something that will be instructive technology that you might be introducing as you can share with us now?
Sure. So the question was around our roadmap and potential disruptive technologies or disruptive components of our roadmap or new features. So, certainly Ansible Works has been around for just about a year now, coming up in February. So there's plenty of ways that we can go, plenty of things that we can do, and it's all customer and market driven. So part of this exercise even is just gathering that data and understanding what the requirements are, what the needs are, and putting that back. I can tell you that the things that are on our roadmap from both an Ansible and an AWX perspective over the next year are things like better integrations upstream with continuous integration tools and source code management. So you'll see things like more formal Jenkins integrations coming in, for example. So it's a very common pathway for Ansible and AWX is Jenkins, and commonly then to a cloud. So we've been doing a lot on cloud integrations recently, and we've seen that even with the last release that came out, I think, a week ago. We're going to do more integrations kind of below cloud level as well, so more VMware integration, more bare metal type things also. Certainly like Google Compute Engine just came live, I think today or yesterday, and they wrote that module, so we're advancing the integrations from that perspective. We'll also look forward to doing more reporting capabilities through AWX and surfacing a lot more of the data that we have that we're generating and make that actionable. And even the last release of AWX had a lot of that in there as well. And then of course there's the support for Windows, right, which we have not tackled yet. We're still gathering requirements for and starting to develop that solution. So that's something that we're looking at for next year as well. Do you have any additions to that?
We have one last question. Please go.
I got a question that what about security when we are automation the process and we're just doing the code and the code is just deployed from staging to production. There are some security checks. Can we automate this also before inside the automation process or not? Such as trying to hack, if I got a form or something, I'm trying to hack it or inject some SQL injection in it and do the testing and see if, with the Jenkins, see if it's go through or not and have these rules in the automation process.
Right, Steve, that's one of the testing requirements in there. So if you're going to put that inside of your Jenkins workflow, then again, yes, Jenkins is going to have the test set up within that. So you're looking for the successful failure of that test as defined within Jenkins. So it's outside of Puppet. That's exactly what I was talking about, and that's what we do as part of the scale testing, which we're doing in Amazon's cloud. Yeah.
Thank you.
Thank
you so much.
So this is the answer that Jenkins can also basically automate security, automate security auditing, automate security checks.
That's a good question, actually. Now, my knowledge of Jenkins is insufficient to know whether you would do security checks inside of that. I mean, if you've got tests which you've written that Jenkins is running that test security, then I guess the answer is yes. You could use Jenkins to actually look at a Puppet report for a particular node that you're testing, and again, that could tell you whether you passed that test. There's various ways of doing it. I think it's, like I was saying to you about how it's quite hard to package up the testing solution, build out these components. There are different ways of doing it, but that's definitely a way you can achieve that.
Thank you so much.